Hello, I'm Mary Wolf. I'm the agronomist at the Aberdeen Plant Materials Center in Aberdeen, Idaho, and I'm going to give a presentation on how to calibrate a seed drill for conservation plantings. This is something that you may want to do if you're doing a conservation planting or if you're a planner in a field office and you want to assist a producer with it. Please refer to USDA NRCS Idaho Plant Materials Tech Notes number 19, number 69, and number 7. These are available at the Idaho PMC website, and if you print them off, it will really go a long ways towards helping you get the job done. Before you get started with calibrating the seed drill, do become familiar with the drill that you're using, and check to see whether that drill needs any maintenance before you use it. When you start your actual calibration, start it from the open position and then close it down to the desired position. Most drills come equipped with a graduated lever for easy calibration. However, older drills may have to be adjusted manually by sliding the opener shaft one way or the other. And you can see in this photo, someone has made some notes based on how they set it, just so that would help them the next time they use the drill. Many seed drills, like the first one I showed you, the company publishes settings for common crops like barley, sorghum, and so forth. Here's an example of one of those charts. The settings that come with the drill may not be very helpful for a conservation seeding, especially when you're planting a mixture of seeds. There's basically two ways to calibrate. The first is you can hook up your drill to the tractor, mark 100 feet on the ground and drive, and then catch and weigh the seed dropped as the drill travels 100 feet. The disadvantage to this is that you have to drive the tractor back and forth until you get it right. An easier way is just to measure the circumference of the drill's drive wheel. Calculate how many rotations it takes of that wheel to make 100 feet. For example, in 100 feet, if your circumference is 4.6 feet, then you have to have 21.75 wheel rotations for your test run. Before you do this, jack up the drill so that the drive wheel turns freely, then turn the wheel the number of rotations. And after you do this, catch and weigh the seed, adjust the settings until the desired weight of seed is achieved. It's very important, though, to always let the drill prime by running it for about 6 feet or several turns of the wheel before starting the catch. That just makes sure that all the seed is feeding through the drill properly. And when you catch that first prime, put that seed back in the seed box and then start your calibration catch. The first example I'm going to show you is planting a cover crop mix, and this photo is the actual cover crop mix that we are going to plant in this example calculation, and we're going to carry this same cover crop mix from putting it together to actually calibrating the drill. The example is a warm season cover crop mix. This one is based on a pure live seed. And if you're not really sure what that means, our NRCS Idaho YouTube channel has another presentation that will explain what pure live seed means and why it's important when you're doing your seeding calculations. So once you have the seed tags and you can calculate PLS, then you can calculate the pounds of bulk seed to go in your mix. The total bulk amount will be used for your calibration. So a little bit of explanation. The first column is the species in our mix. The second column is the full pure live seed rate. The third column is the percent of mix that we've chosen for each one of those species to be. The mix PLS rate is what proportion you're going to finally end up with. The PLS column is the pure live seed, that is the number that you get from the seed tag. And then when you multiply that out by the full rate, you get the bulk rate. And down in the bottom right corner is the total bulk amount. You have to go through this whole set of calculations before you know exactly how much you want your drill to plant. And then to start the actual calibration, the first step is to calculate the area of a 100-foot test run based on the width of the drill to be used in the seeding. In our example, the drill is 5 feet wide and it has 9 openers, and we know from the previous slide that we want to plant our cover crop at a rate of 34 pounds per acre. So the calculation is the 5-foot width times the 100-foot run divided by the number of square feet in an acre, and that gives us 0.01 acres that our test area is going to be. The second step is to calculate the amount of seed mixture required for the test run. So 34 pounds an acre times 0.01 acres gives us 0.39 pounds of seed mix for our calibration. The third step is to determine the amount of seed that will be delivered through each drill spout during that test run. So you need to know the pounds of mix for the test run, and then divide that by the number of spouts on the drill, and that's going to give you the pounds of mix that's going to come out of each spout during that test run. We have 0.39 pounds of seed mix for our test run from the previous slide. We know there's 9 spouts, and we can calculate that we need 0.04 pounds of mix per spout. That's kind of a weird number to measure, so it's best to convert it to grams, then you can weigh it on a kitchen scale. So we come up with 20 grams of seed mix per spout. Now that we have amounts, how do we know which drill setting to use? In this example, the drill that we're going to use for this calibration comes with those crop charts I was talking about earlier that are based on bushel weights. If you have an older drill that has no charts or marked settings, you're just going to have to wing it. So the first method to figure out which drill setting to use is to use the bushel weight of the predominant seed in the mix. If your chart doesn't show that seed, then use a crop with a similar bushel weight. For example, if your predominant seed in your mix is millet, which has a bushel weight of 60 pounds per bushel, then use the drill setting for peas, which is 61 pounds per bushel, or sorghum at 60 pounds a bushel. The second method, which is actually more accurate, is to calculate the actual bushel weight of the seed mix yourself. It's actually very easy to do. You can just look at Plant Materials Tech Note number 69. It'll take you through the steps. We'll go through them now. You pour your seed into a 1-cup kitchen measure and level it off. Don't pack it. Then you weigh the measured seed in grams and multiply the weight by the conversion factor of 0.328. We have a really fancy gram scale here from in our lab, but you can just use a kitchen scale. It doesn't need to be to thousandths of a gram. So in our example, and this is our actual cover crop mix, 1 cup of the mix weighs 152.8 grams. Multiply that by the conversion factor and we have 50 pounds per bushel. In this case, we're going to set the drill for barley, which has a bushel weight of 51 pounds per bushel. This will be a good starting point, although some fine-tuning may be required later. Here's the crop chart from the manufacturer's manual for that drill. You can see that we're going to start at drive type 2. That's just how we have our drill set up. So under the row for drive type 2, we see 35 pounds an acre. We're at 34, so that's pretty close. And going up to the top for the seed rate handle setting, that puts us at handle setting of 30. Now that we know how much seed the drill should plant and what the drill setting to use is, we can start the calibration process.
Go.
So here we are in the farm shop. We're going to do our actual calibration now. This drill has 3 seed boxes. The one in the very front is for tiny seeds. This one is for fluffy seeds. And this is the main seed box, which is the one we will be using for the calibration. Right here you can see there's some gear settings, and this one is on 2. That's really important because when we start to look at our chart, and we're going to go off barley because the bushel weight was the most similar to barley. So at drive type 2, for our goal, which is 34 pounds an acre, the closest is 35, and that tells us to start at the setting of 30. And that's what we're on right now. That groove in the middle of the bar is on 30. So that's just, seems like a good starting place for us. And so we know that we can go 100 feet without actually having to drive this thing 100 feet by measuring the circumference of the wheel. And that way we can figure out how many times this wheel has to go around to make 100 feet. The circumference of this wheel is 55 1/8 inch. And when you do the math, for 100 feet, the wheel has to go around 21 3/4 times. The next thing we need to do is come over here, and you can see that there's some tubes that go down to the openers from the seed box. We're going to take 2 of those off, and we're going to put buckets to catch the seed. This is our cover crop mix, and I've already got some in the seed box. The first step before you actually start catching to measure is to get the thing primed, to get the seed going from the box down through the holes. So just take that handle around a couple times, and this handle makes the wheel go around. With some drills, you just have to sit there and push the wheel yourself, but on this one we get to use the handle. So I'm going to take what dropped. We don't want to weigh it. It just goes back in the seed box. Now it's actually calibration time. 21 3/4 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 3/4. Now we'll get the buckets. And weigh them on our kitchen scale to see how close we got to the 20 grams we need from each spout. We'll tear the scale. So that spout gave us 25 grams. That's a little high. That one also gave us 25. It's a little bit high. So for drive type 2, the next setting down at 25 is supposed to give you 28 grams. I'm going to try that one and just see what it gives us.
Let's empty those buckets.
Well, I'm going to prime it.
Oh, okay.
Yeah. So you can see I'm back around at my starting point, and I primed it a little bit. Okay, round 2. 1, 2, 3, 4, 5, 17, 18, 19, 20, 21, and 3/4. It looks pretty good. You only get so close, so I'm going to call that close enough. The second calibration example we'll go through today is for a range seeding. Here's our example seed mix. We have native grasses and forbs. Similar to the chart I showed you previously, we have for each one the percent of the mix that each species is going to be. We have their pure stand seeding rate in pounds per acre, and that comes from Idaho Plant Materials Tech Note number 24. And then we've multiplied that out to have the rate in the mix. And at the bottom, in the bottom right corner in yellow, that's our total bulk amount. You'll notice that for the cover crop, our total bulk amount was a lot more. This is a really small amount of seed per acre, and there's a lot of drills that aren't going to be able to seed this light. There's a way to get around this. We can use rice hulls or some other carrier. In this example, we'll use rice hulls. Many types of carriers can be used, but the rice hulls are the most effective and cost efficient. We always use number 1 grade rice hulls because they're clean and unbroken. When you look at them, you can see that they kind of form a little cup, and those cups can help hold small seeds. We use them with seed mixtures when we're planting low seeding rates or different size seeds in the same mix. The rice hulls prevent seed separation in the mix while planting, and they keep the seed mix flowing through the drill. To find out more, and for the next slide, we're going to use Idaho Technical Note Plant Materials number 7. And this tech note at the end has an Excel spreadsheet that's actually a rice hull calculator, and you can put in the information that you have and it'll do a lot of the calculations for you. You can see I've put in the species we're going to use, the percent of the mix, the pure stand seeding rate. I've got the seed tags, so I put in the percent PLS. And you have to know pounds per bushel. A lot of these are in Tech Note 7. They've already been predetermined for you. But if you're planting a seed and you can't find the pounds per bushel, you can just go back to the method I used in the previous example, where you just level off a cup measure and then multiply the gram weight by the conversion factor. So when you plug in all those numbers, it's going to tell you your required bulk seed for the area that you want to plant, and it's also going to tell you how many pounds of rice hulls you need. There's a little bit more information you can put into this spreadsheet. You need to know the width of your drill, the length of your test run, the number of spouts on your drill. And when you put in those numbers, it's going to tell you how many grams you want to measure out of each spout to have the nice rate. It even tells you the drill setting. So this drill setting, it says 1 bushel of barley, and that just means that we can use the same setting that I showed you on the previous example for barley. And I would like to point out, in this example, we are using a different drill with a different width and a different drive wheel. So we have one more step. The only step left is to measure the circumference of this drill's drive wheel so that we can do the 100-foot test run. Then we can begin to do the actual calibration, adjusting the settings until we're getting about 9.5 grams of seed mixture per spout. Some more considerations when you're doing a range seeding. In the video, I pointed out that the drill in that example had multiple seed boxes. If you are using more than one seed box at a time, say a large seed box and a small seed box, or you're doing an alternate row seeding, both mixes will need to be calibrated separately because each seed box has its own set of tubes going down to the openers. And remember to count only those spouts that will drop that specific seed mix. So that concludes my presentation on calibrating a drill. If you ever have any questions or you need some assistance with doing your calibration or a seed mix, please contact me or the manager of the Aberdeen PMC, Derek Tilley. And thank you very much for your attention.